Hey everybody, thanks for having me here at Frontend Nation on this wonderful day 2, or if you're watching VOD, whatever time it is. Let's dig right into it actually. You see nothing, and I want to show you a little test. Maybe you know that. What do all of these frameworks you will see in a second have in common? And maybe for bonus points, can you name all of them? Feel free to write them all in the chat. I'm having to open in the meantime. So you see a couple of these frameworks. You might have used one or two, or well, if you used all of them, that would be crazy. And the question is, what do they all have in common? The answer is this wonderful thing, Vite. So let's take a closer look at how this is related to modern JavaScript tooling. And we'll explore some parts of the future of Vite as well. So let's get into that. A few words before Konstantin already announced me pretty well. I'm a developer at VoidZero, so we'll talk about a few things that happened all around the tooling ecosystem, also a web engineering consultant, giving talks, the Next.js team, and I also do some YouTube on my own channel, also at live streaming every now and then, also on the VoidZero YouTube channel as well. I'm available on all kinds of social media, so if you have any question, then straight away, please shoot them over in the chat for the Q&A or also later on. Okay, and I also have a website, but well, ain't nobody got time for that, right? We know the problems. So, the current Vite stack. Well, what do we have at the moment? And maybe have a closer look here. So let me move myself over up here so you can see the slide numbers, and let's see. So Vite under the hood uses a couple of tools and bundlers actually. And one of them is ES-build, pretty common for pre-bundling, for transforms, and also for minification, but often used, as said, dev server, and eventually running through your rollup bundle after rollup bundled it. And talking about that, of course, also rollup, right? The main bundler for production. You have all of these plugins that you can use and that are also sometimes part of Vite plugins. And of course, you can also define things like, which chunks should be set in what way, but it's quite limited. So we have that. And there's one more thing we actually have, but that's more for the React folks, right? SWC. If you don't use React, you probably have not heard of that. Maybe you did. That's great. And you're interested in build tools as well. And it's an alternative to do transforms, also important for React Fast Refresh. That's actually the only tool that's written in Rust here, SWC. We have rollup in JavaScript and ES-build in Go. So all different languages, different technologies. And that also means complexity, right? So what do we do now? Well, we take Vite to the next level and replace these things with just one single dependency, or in this case, one single bundler, which is called Rolldown. And now some of you might wonder, Alex, come on, why do we need yet another bundler? It's a bit like yet another framework, yet another tool, but I promise you, this is a bit different. So let's look into that. First of all, well, it is an issue that we have two bundlers in Vite, or if you have SWC, another tool as well, and that brings increased complexity. Not only that, we also have the problem that you have inconsistencies between development and production, because ES-build has a limited scope compared to rollup. ES-build doesn't bundle. You have an unbundled dev server there. So that's also why Vite is quite fast, right? And why a lot of people adopted it compared to Webpack or similar tools before. So that's an issue. And of course, there's once again more. We also have limitations that, for example, rollup or ES-build both say, look, we don't want to support certain parts. It's out of scope. We don't have the bandwidth. It's simply not planned. And that's, of course, also a limitation for certain features. And last but not least, all bundle builds, right? The dev mode is pretty fast, but all bundle builds could be a bit faster. So it's time to meet Rolldown. And Rolldown, well, the name sounds a bit like rollup, but different. Now, I already mentioned it's based on Rust. So is it just a Rustified rollup? No, it's not. Because otherwise, people could just say like, hey, let's, fork rollup, contribute to it, and call it a day. But it's not. And that's a very important takeaway here. So this is basically the best of existing and prior art. Let's take a look. Of course, if we switch out the bundler in Vite, it should be compatible to all the things we have there. So of course, we stick with Rollup's simple and flexible API. And we also want to ensure that we have the compatibility to the plugin ecosystem. So in Rolldown, you'll be able to use Rollup plugins as well. You might not need some of them because they're built into Rolldown already. For example, Rolldown can do things like transforming JSX out of the box and a few other things that you don't need a plugin for. But in general, all plugins are compatible or will be, with some exceptions as usual, but the majority will be fine. Also, of course, ES builds amazing speed and certain options like inject, define, and so on. So we'll also take a look there, what we can use. And last but not least, I mentioned the name before. So some of you might remember Webpack. Yeah, and Webpack was really good at optimization features like fine-grained chunk controlling, saying, okay, we have chunk groups, we define where certain chunks should go. So that was a thing Webpack was really, really good at. And of course, they can also their inspiration, given credits, say, okay, we want all of the good things there. And that's not the end. There's, of course, more than just taking what was there before and like re-implementing it in a different and more performant language and making it more performant. We also want to do a few more things. Like we want to integrate module federation. We want to have HMR built in. Actually, these are all existing features right now and experimental, and also CSS bundling. And of course, as mentioned, there's much more beyond that. Minification is another thing, right? We do this via OXE. And if you haven't heard of OXE, we'll get there. But for now, that's more or less an overview of Rolldown as a bundler. But if we say, okay, let's unify the bundler, so let's do the best of all the worlds we have, ideally without huge trade-offs, why should we stop there? And actually, we shouldn't. It simply does not stop there. Then building a bundler is not easy, right? As said, it's not even a different language. It's, in this case, Rust, right? But there's also, you need certain tools. You need a foundation to build a bundler on top. And that part, well, you need a foundation. So let's meet OXE, the JavaScript oxidation compiler. And if you've wondered, if you've ever seen the logo before, yeah, it's an anchor, correct? It's Rustified because, well, it's Rust tools. And how's Rust being created? Well, through oxidation or oxidation in this case. So that's the story behind the logo. I love that story because the first was also like, why an anchor? And it's so good. Okay, let's take a look at the parts of OXE there. First of all, OXE has a parser, right? Rolldown needs to parse some files, and you can also all use these parts separately. So you can use the parser in projects or whatever comes next. It's actually the fastest parser out there. It's 3 times faster than SWC that we've seen before, and it's spec conform. Conformance is very important there, so it passes the ECMAScript conformance test suite, the test 262 suite, with all stage 4 tests. So that's great. Awesome. Also, if you're interested in the benchmark links, they're always highlighted over there, so you can have a look at these later on. Then the resolver, yeah, it's also the fastest resolver out there. It's 26 times faster than the original enhanced resolve. So that's also a pretty great accomplishment. And we're not stopping there. Also, so resolving is necessary to say, okay, where are certain modules located, right? We have CJS and ESM and need to resolve all the modules. But there's also, once again, the transformer. So we also want to, for example, say, okay, let's do syntax lowering. Let's change the target. Let's replace certain parts of our written things, like the nullish coalescing operator should be replaced with the code doing the same. And all of that can be done with transforms, usually define like a browser target and do a few more things around that. And the OXE transformer, well, it's the fastest one once again. It's 40 times faster than Babel. Yeah, it's not 40%, and 4 times faster than SWC. Also, what you often want to do if you have like a library, you want to emit your d.ts files, right, for TypeScript support. And if you enable isolated declarations, well, then this is roughly 20 to 45 times faster than using TSC. And regarding TSGo, it's not included in the benchmark, but TSGo should be roughly 10 times faster. So I suppose at the moment would be then 2 to 4.5 times faster than TSGo. But benchmarks have to be made around that. Just would make sense. Of course, once again, that's not the end there. We also have a linter, and that's more interesting part for you if you're not building a framework or a plugin. It's more like if you're the web developer who wants to consume things like using Vite or a framework, then linting is something interesting. Oxlint, that's the name of the linter. It's 50 to 100 times faster than ESLint. Yep, that's not a typo there. So it's pretty fast. And Last but not least, we have the minifier with the best speed compression combo. So it's neither the fastest nor the one that compresses the most efficient, because usually if it's the fastest, it lacks in compression, size reduction. And if it's not the fastest but the best compression rate, then it's usually taken quite a while. And we have kind of a sweet spot there actually. So that's also looking good. There's also a formatter work in progress that's pretty compatible, and also does some sorting later on. We work on that, so updates on that soon. On that note, let's talk about Oxalent, because I think for you that's the most interesting part out there. Let's give some updates. As mentioned, it's 50 to 100 times faster than the ESLint, and speed alone is great, but that doesn't help, right? If it only supports one rule. Luckily, it doesn't. It supports 500, actually more than 500 rules that are ported over from the most popular ESLint plugins, the ESLint recommended set itself, and so on and so on. So it's looking pretty good there. Also, it's used in the majority of projects, actually. It's used in Preact, Bun, and Vue, where the PR is open to change it, but also internally at Shopify, Airbnb, Mercedes-Benz, and many, many other projects. So if you want to replace the ESLint and you focus on JavaScript and TypeScript and JSX, then you're kind of good to go. The good thing is also there, V1 is on the horizon, so that is coming up. We're tying things together to get it up and running. So also then folks saying, okay, it's not stable, let's wait a bit. The glorious 1.0 comes and you can use it. There are a few things that are work in progress that I want to give some updates here. And the most common thing is custom lint rules, right? It's a Rust-based linter. So what do? Well, we don't necessarily want to write all the rules in Rust. So if you have custom lint rules, or you use that one random package that only 10 people use in NPM for the lint rule you like, well, good for you. We're looking into that. The idea is being as ESLint compatible as possible. Of course, we want to make sure we have a good balance between performance and compatibility there, because it also doesn't help to say, hey, we support 100% and then we're just as slow as ESLint can be. So we try to find a good trade-off there. We'll keep you posted on that and working on that. Of course, another thing that's not supported yet, but is coming, is a more fine-grained configuration to say, for example, this glob, you can change certain parts, you adapt rules. There's already a configuration possible based on files, but we're getting there a bit more fine-grained. So think of like ESLint v9 configuration. That's something we're looking at. And of course, type-aware linting is also a topic that we're taking a closer look at, because that's also a thing a lot of you use out there. And last but not least, as a little example here, you can see, how fast Oxalent actually runs. This is one of the biggest repositories Oxalent ran, with 101 rules and 10 threads. It's finished in 22.5 seconds. And yes, it ran over almost 265,000 files in only 22.5 seconds. And that really includes all of the process from, we have to read the content, parse it, apply all the rules, and that's pretty fast. I know some ESLint setups in, of course, projects that are way, way smaller than that run in minutes. So if you have these problems, if you feel like, it would be nice to have a faster linter out there, there it is. You can already use it. Just install the Oxalent package. There's even a migration script, which is pretty nice. So if you have an ESLint config set up, you can run a migration script. It will port over all the rules that are available in Oxalent. If you have some rules that are not available, you can even use them in tandem. That should also give you quite a speed boost, depending on the rules you use. So there's not much stopping you, especially after V1 comes out. And honestly, working on, Rust-based tools in the JavaScript ecosystem gives some challenges, some, let's say, low-level challenges. So for example, how can we reduce the overhead between JavaScript and Rust? So let's say if you have a plugin for Rollup, which can also work in Rolldown, of course, and you write it in JavaScript, that's fine. But how do we make sure this is called performantly optimized? Or how can we transfer data efficiently, and so on and so on? I want to give you a little insight on what's happening and things that we've implemented and improved. And the first thing is this: a very common way of writing a Rolldown, Rollup, and so on plugin, same API almost, right? We have a name for it, let's say example, and we set in transform, we want to do something. So for example, if the name, right, the ID, the identifier ends with .data, then do nothing. Otherwise, perform some stuff on it. or the other way around. If it's so everything is not data, it doesn't matter. If it's not data, do something. Great. But now we have a problem here and it doesn't matter if it's Rust or JavaScript. That hook is called on all the files, not only on the files that end with .data, because how would you know, right? So at the moment, the function has to run all the time. Of course, then we can early return. We don't have to execute the actual heavy part. But if you run this over a lot of files, it also adds up. So that's a problem. This specific part here. We don't know where that function should or shouldn't run. And luckily, there's a solution for that. And the solution, as the heading says, is called plugin hook filters. So let's see here, instead, we have a handler for the transform function. We have a filter object. So here we can say, please filter the ID based on it should end with .data. And the best part here is that in JavaScript, okay, you don't have to call the function anymore because this is implemented in Rollup, in Vite, and of course also in Rolldown. And the good part is that Rust understands regex, JavaScript does, so it can be used in all cases. And no matter if it's Rollup or Rolldown, we can skip that function for all the files that are not necessary. But this will especially improve in the Rust-based scenario because the calls, the overhead, they are quite costly. So yes, let's not execute a hook each time. We can filter by regex. We can also do more complex things, actually. We could say we take the code that should include a certain regex and the ID, and then have another OR. So they're also more complicated and more complex, and hopefully not more complicated scenarios that you can cover. There's even an extra package for that to do that in JavaScript, and then Rolldown will do it in Rust by itself. So yeah, and as mentioned, this works in Rolldown, Rollup, and Vite. So we're good there. Now, let's come to the other part I mentioned. So how to serialize the AST and send it from Rust to JavaScript. Let's zoom out a bit. So AST, as the abstract syntax tree, is basically the definition of how the code looks like. So don't have this, the code is a string, but actually a tree saying, oh, this is a certain node, it has child nodes. So you have an actual tree, a formal representation of the source code. And there are a few challenges. So creating a tree from the code is one thing, creating that in Rust, and then sending it over and having the same thing in JavaScript. So you need to either align the representation or find a way to, once again, serialize that, send it over. But actually, the answer is you don't serialize it. The best way to deal with that is just send over the whole memory block as a shared array buffer, because then you don't have any serialization cost. And that's a pretty sweet thing. It reduces the overhead dramatically. Also, it allows the lazy deserialization. So let's say you're only interested in certain nodes of that AST, so certain functions, certain variables. Then you don't have to bother with like serializing the whole thing, but just saying, or deserializing, just saying, okay, whenever I need a certain node of a certain shape, then I can start and deserialize and parse that. So a lot of potential here to go. And last but not least, we all, if you write a Rollup or Rolldown plugin, if you've ever written a Rollup plugin or do some, typical like walking the AST, doing things, you have a magic string as an API to say, hey, let's change the source code wherever we are. And that all works pretty well. The best part is, though, we're looking into, and we're exploring that, to move the execution parts to the actual rewriting to the Rust side. So you basically just send over the instruction and say, okay, at this line, let's change that, and let Rust handle the rest, which will increase the performance even more. And of course, that will also allow for a more performant hook later on for Rolldown. And same thing for Oxidant, especially. Look into how we can run rules in parallel on the JavaScript side, like spawning workers, for example. There are a lot of options that we can look into there. But it's all comes down to improving performance more and more. So yeah, that's, I think, all around the small updates from the low-level challenge and how we solved them regarding the tooling, both on the OXC side and also on the Rolldown side. Let's have a look at Rolldown Vite, because once again, we talked a bit about Rolldown, we talked a bit about OXC. You know that you can use the linter already, you can try out the other parts. But the interesting thing there, well, what is with Rolldown Vite? What are the plans there? You might have read the announcement post. So we are in phase 1 already. A couple of days ago, the post came out that now there is a Rolldown Vite package. You can use it already to test it. It should be a drop-in replacement. So you can just alias your Vite package or use an override, and then you're good to go. So that's phase 1. In phase 2, so when you've tested, when a lot of people looked into that, we could fix some problems if there's any, and there might be. We're also like developing more and more Rustified things, so there are also flags that you can set, experimental flags to try things out. In phase 2, there are two important things here. One thing is a full bundle mode for the dev server as opt-in. I'll explain that in a little bit. And of course, when things are stable, and that's very important, when things are stable and battle tested, they will be merged in the main Vite package. So that won't happen for V7. We'll take a bit of time to go through these thoroughly. We want to make sure that you all have a good experience. So for those who don't want to test out and just you're like, okay, that's cool, I'll test it when it's ready, that's also fine. I'd encourage you to test it right now because it's pretty fast. But if you say, hey, no time whatsoever, at some point you'll get the goodies. So that will happen. And then Rolldown is the default bundler for Vite. Cool. And then there's phase 3, actually. There's one more phase. And that phase actually just says, okay, let's move the full bundle mode as the default. And now I've mentioned full bundle mode 2 times. You might wonder, what's that? Like, what is full bundle mode? Why is it interesting? And what does it mean for me? And the answer is, luckily, well, probably not that much unless you work on a huge application. So to make it a bit more graspable, Vite's dev server, we all know it's unbundled, it's super fast. So instead of saying, like, for example, Webpack is doing that, let's bundle things, then you have the server after, well, ideally a couple seconds, but more like half a minute, depending on the project size, right? Or even more time. Vite does it differently, right? It does not bundle it. So we use dynamic imports to just say, like, okay, here's the entry file, everything else, you just send a request, you get things over. There are a few things that are happening, of course, thanks to ES builds mentioned before. But nevertheless, these are fast because ES builds written in Go, and we simply don't do that much. So that's great. But it is slow if you have a huge project. So if you have like an enterprise level project, not like with 100 components, maybe not 500, more like 1,000, 10,000, something like that, or even files, dependencies, you have a problem. Because then, of course, each of the dependencies, you do a little bit of pre-bundling, but it's a request. So yeah, we end up with, worst case, tens of thousands of requests. And that also means if you then have a corporate proxy, right, because you're in an enterprise environment, they will all have to go through there. And that's very slow. But that's very important for the dev server and production. It doesn't matter, but you also want to ship features and test things. So you want to have a fast dev server as well. And for these cases, well, they would perform way better when there's actually some bundling involved. And now we don't want to go back to like the half a minute Webpack, but that's also why we have Rolldown. It's really, really fast. So the goal is for the full bundled mode to say, okay, let's bundle the dev server again with Rolldown and have ideally the same or better dev server performance than it is right now for small to medium projects. And of course, a way better dev server startup time, hard reload time, the performance for large projects. So we want a best of both worlds, so to say. And if you wonder now, okay, that's cool, that's great, but how fast is it actually? Well, we see a 2.5 to 16 times build time reduction with Rolldown Vite. There's a repository, happy to share the link in the chat after the talk. It's called Rolldown Perf or Rolldown Vite Perf Wins, where a lot of people listed, and I've also added some from social media, their wins saying, okay, 16 times build time reduction, or GitLab, for example, reported up to 100 times memory reduction during build, which is huge, of course. So many resources, so much CI time that's free, and then you're good to go. So as mentioned, you can try it out right now as the Rolldown Vite package. There's a guide at vite.dev/rolldown, so make sure to look into that if you're interested. We'll also post the link in the chat in a second. And yeah, then you're good to go. If you have any kind of Vite project, it doesn't matter if it's based on a framework, if it's plain, I don't know, React, Vue, Svelte, or if it's like a Svelte kit. Also, frameworks are more and more integrating as well. So if you hit any issues, feel free to raise an issue in the Rolldown Vite repository. And of course, to say that, that's not the end yet, right? We at VoidZero want to unify the whole toolchain because there it starts. Okay, which bundler to use? Kind of solved that. Which parser, minifier, formatter, linter? We're getting there, right? But then there's also more, like monorepo support, for example. And ideally, you have one toolchain that uses the same tools. We benefit from caching. Things are super fast. So that's the goal for the long term. But honestly, I think that's for another talk. Thanks a lot to my sponsors on GitHub. I always want to mention that so I can thank them for supporting me giving talks, and of course for my open source work that I also do in the Vue Next ecosystem, and more, of course, Vite related things. And I want to thank you out there for your attention, and I'm ready for your questions, folks. Thank you.
Hey, thanks a lot for this talk. It looks very interesting for everybody in terms of builders, because when they go fast, everybody likes it.
Oh yeah, nobody hates like, hey, it's going 10 times faster now.
It's like but too fast, man. I hate it.
There goes the coffee break, man.
Yeah. By the way, we have a lot of questions, so sorry. Perfect. We will not be able to answer all of them. But again, Alex is available anywhere, so you can ask him directly. Also, some of them are a bit too specific, so yeah, better suited for a GitHub issue. But this one, maybe for someone new to those tools, how do you think that they can start integrating Rolldown or OXE?
Yes. So ideally for Rolldown, I think it's a pretty easy answer. You can use Rolldown Vite as shown. So if you use Vite, just have an alias. It's a lovely migration guide. And vite.dev/Rolldown, also post that link in the chat. And if you're watching the VOD, I probably put it somewhere here or it's in the description. So you can just alias Vite and you're good to go. In terms of OXE, try out Auxlint. If you're watching this in the formatter's already out, so a bit in the future, also try the formatter. Everything else is, well, if you have certain parts that you build yourself, certain plugins you write, you can use OXE for that as well. But as like the average web developer shipping features, building applications, the easiest is like, go with your team, try out Rolldown Vite. A bit like you probably want to try out TSGo when it's there and super fast. And I think that's a good start. And if you have any issues, once again, just shoot a DM, tag me on any socials, and I'm happy to look into that.
Perfect. Next question. How do you see the landscape evolving with those Rust-based tools?
It's super interesting because, of course, we're also not the only ones trying that. Have to like fully admit that there's Biome, the fork of Rome, right? There's also like Bun doing more and more, the whole like R stack. So it's interesting to see that. Well, in a way, a lot of people agree that a unified toolchain would be nice. And giving the foundation, everything that we build around Vite, which is more or less like some kind of shared infrastructure for all the modern web applications, I think we're on a really good road there. Honestly, for myself, I don't want to bother of like which formatter would I use, which linting rules. I just want to have like one thing to go and things just work. And that's in a way the dream and the idea that you want to do. So if we can achieve that, I'm happy.
Yeah, nice defaults where everything works out of the box. Yeah,
exactly.
That's the best way. Speaking of Biome, is there any collaboration happening between them?
So, of course, we are in touch with folks. Actually, Biome was until very recently using OXE Resolver. Now I think they use a fork or like at least partial fork out there. But of course, like we're also, in general, it's open source. We're closely looking what people are doing, what we can improve for our ecosystem, what we tend to avoid doing. And Biome is going a slightly different direction. I personally am really curious to see how that will go. So yeah.
Perfect. Yeah, tight collaboration in open source is always beneficial for everybody. So
exactly.
Yeah, I think that's pretty much all for our questions. Again, sorry we couldn't answer all of them, but feel free to reach out. And
exactly. Also jump in the chat right now. So yeah, thank you for emceeing.
Also. Yeah, thanks a
lot.
All right.
Enjoy the conference. See you all.
See you.